This is example 3.6.8 from the book. In this example, we're trying to differentiate the composite function negative secant x squared plus 7x. And in order to do this, we're going to need to use the chain rule, which tells us that the derivative of such a function is equal to f prime of g of x times g prime of x. Now, the book has already broken it up for you into the component functions of f of u is equal to negative secant u, and g of x is equal to x squared plus 7x. So we need to find out what f prime of g of x is and what g prime of x is. So in order to find out what f prime of g of x is, we're going to need to know what f prime of u is. So that's simply the derivative of f of u. So this is negative secant u tangent u. Now, in order to get f prime of g of x, we're going to plug in g of x, which is x squared plus 7x for u. And we're going to get negative secant x squared plus 7x tangent x squared plus 7x. So now that we've got f prime of g of x, we need to get g prime of x. This is simply the derivative of g of x, which is x squared plus 7x, which we know to be 2x plus 7. So now that we have both f prime of g of x and g prime of x, we can put them together to get our derivative. So we know that our derivative is equal to f prime of g of x, which is negative secant x squared plus 7x times tangent of x squared plus 7x times g prime of x, which is equal to 2x plus 7. And that's our answer.